Good morning, ladies and gentlemen. Yesterday, actually, you were working on writing the equations, different forms of quadratic equations and functions, and you kind of tackled vertex form and factored form, also known as intercept form, yesterday with Mr. Myers, and today we are going to do standard form. Okay, standard form is the fun one. Standard form is the one that's kind of tough. And there's a warm-up here on your packet. And the reason there's a warm-up is because we have to remember how to solve systems of equations in order to do this. So before we get there, hit pause. Try to solve these two systems of equations to make sure you remember how to do it. And as soon as you're done, unpause and make sure you come on. So to solve a system of equations, we're going to use the elimination method here, which is we're going to stack our equations on top, and we want to make sure the coefficients of either x or y, when I add the two equations together, are going to eliminate. And so when I add these two, because I can see the y has opposite coefficients on it, so when I do this, I can see 3x plus 2x, I get 5x equals, those actually go away, and I get 5. So I get x equals 1. And now that I have x equals 1, I'm going to use either equation, either original equation. Just for fun, I'm going to use the top one. And anywhere I see an x in it, I'm going to plug that x in it. So I'm going to have 3 times 1 minus 2y equals negative 5. Well, that gives me 3 minus 2y equals negative 5. Smartboard is being dumb. So negative 2y actually is going to equal negative 8. So y equals 4, right? So I get an x equals 1, a y equals 4. Well, the actual solution to a system of equations, because this is a line and both of these are lines, the solution is where those two lines intersect, which would be at 1, 4. Okay, so that would be the solution to that system. Number 2, you notice the coefficients are not opposite on either one of these, and you can get rid of x's or y's. I kind of look into my y's because my signs are already opposite, and what I'm going to do is I'm going to take the top one and I'm going to multiply that by 3, and I'm going to take the bottom one and I'm going to multiply that one by 4, because that way my coefficients on the y will be opposite. But I got to multiply the whole equation by that. So I get 9x minus 12y equals negative 18 times 3 is negative 54. And then I take 8x, because I'm doing the bottom one by 4, plus 12y equals 20. And now that I have a set of terms that are opposites, okay, because they're going to go away, I get 17x in this case equals what? 34. Divide by 17, I get x equals 2. Well, that's only half of my ordered pair. That's 2 comma. What's the y? And I'm going to come back and I'm going to grab either one of the original equations before they're multiplied by those numbers, simply because that gives me smaller numbers to work with. I am going to pick, well, it doesn't really matter which one I pick, except that was a negative 34, and that's a negative 2, which makes that 2 negative. Way to go. I'm going to pick the bottom equation, then I'm going to plug my x in just because the numbers are smaller, and 2 times negative 2, that's going to give me negative 4, plus 3y equals 5. I'm going to add my 4 across and get 3y equals 9, so y has to equal 3. Okay, so my point is negative 2 comma 3. If you remember how to check your answers, okay, I'm not going to go through and do this just to keep the video short, but if I take this x and this y and I plug it into this top equation, in this case I should get 18 equals 18, meaning I should get a true mathematical statement. Not only in the top one, it's got to be true for both of them. And when I plug that x and that y in, as long as I get a true statement out of both equations, I can be confirmed that I did the problem correct. Okay, now we're going to look at some systems of equations on steroids, I'm going to call them, because these 3 points here, these are all random points. Okay, yesterday when you did factored or vertex form, they gave you the vertex and a point so you could plug into the vertex form. Or they gave you the x-intercepts, intercepts so you could plug into factored form with a third point. Well, here, they're not giving me anything. They gave me the y-intercept and 2 random points. So because of that, I need to be thinking of f of x equaling ax squared plus bx plus c, okay? And I'm going to utilize all 3 of these points the same way you utilize all the given information they gave you before, okay? And what I'm going to do is I'm first going to utilize the point -1, 5. If I take this x and this y and I plug it into this equation, what I get, remember f of x is just a y, so I get 5 equals a times -1 squared plus b times -1 plus c. I'm just plugging all the x's and y's in there. Well, this gives me 5 equals -1 squared is 1, so I get a minus b plus c. That is going to give me one equation. I got to grab my next point of 0, 3. And I'm going to plug that one in there. And that's going to be 3 equals a, and I'm going to say my 0 squared plus b, and I'm going to plug my 0 in, plus c. So I can see 3 equals c, which is nice because in the end I need to know what a, b, and c are so I can write all those values. And the last one I'm going to use the third point, 3, 9. And when I plug that little squirrel in there, I'm going to end up having 9 equals. Now, I'm going to say 3 squared is 9 times a is 9a. B times 3 gives me plus 3b plus c. Okay, so now that I have this, I need to know what a, b, and c are. And because technically I have 1, 2, 3 unknowns in an equation that I'm solving, I'm going to have 1, 2, 3 equations to utilize that with the same variables in them to solve it. The same way in the previous warm-up, if I had an x and a y in an equation and I needed to solve it, I needed 2 equations with the same variable. Well, if I got 3, now I need 3 equations. The way I'm going to tackle this now is because I already know what c is, I'm going to take that c and I'm going to plug that little bugger right into this equation, and that's going to give me 5 equals a minus b plus 3. So I know a minus b is actually going to equal 2, all right? As long as I'm doing this correctly, which I think I am. Okay. And then I'm going to do the same thing. I'm going to plug the c into this one. That's going to give me 9 equals 9a plus 3b plus 3. And I'm going to subtract that 3 over, and I'm going to say 9a plus 3b. Well, that's going to equal 6. Okay, so now I have 2 new equations. I have this one, and I have this one. I have a system of equations with 2 variables in it. Well, I need to multiply these 2. Basically, what I'm going to do is I'm going to take this one down, and I'm going to say, okay, 6 equals 9a plus 3b. And I'm going to take this other one here, and if I want to get rid of, I see my signs are opposites on my b's. So if I multiply this equation by 3, what that's going to give me, that's going to give me 6 equals 3a minus 3b, so that I can actually add these 2 together. My b's are gone. What I get is I get 12 equals 12a, so that would mean a equals 1. So now I have a, I have c, I need to know what b is yet. Well, what I can do is I'm going to come back to any one of my original equations, okay? This one's not really going to work very well because it doesn't have an a and a c in it. It only has a c. And I'm going to pick this equation, my equation number 1. And what I'm going to do is I'm going to plug both my a and my c in it at the same time. to find out what B is, okay? So to do that, using, I'm going to say 2. Am I going to say 2? Where am I at? I got to get that. I can't see that little bugger up there. So I'm going to say 5. I'm going to say 5 equals, my A is 1, minus my B, I don't know what that is, plus my C is 3. That's a bad 3. But I can see 5 equals 4 minus B. So I subtract, I get negative B equals 1, so B should actually equal negative 1 once it is all alone. So now I'm going to use all 3. I'm going to use A equaling 1, B equaling negative 1, and C equaling 3, and I'm going to plug them right into my function form of f of x equals ax squared plus bx plus c. And when I plug those in there, okay, what I get is I get the quadratic function f of x equals, well, if a is 1, 1 times x squared, that's just x squared, plus b, well, if b is negative 1, that means minus x, and c is plus 3. What I just did is I found the equation of a parabola, okay, you can actually graph that on Desmos, and you will see that this equation passes through all 3 of these original points right here, and because it passes through all 3, we know we did it right. Okay, now that seems like a lot of work. It is a lot of work, but that was an easy one. Number 2, we're going to come to the next one here, but we need to do the same exact thing, okay? And I'm going to move this guy up. We're going to do the same thing. Create a system of equations, because I'm thinking, in the end, f of x equals ax squared plus bx plus c, because it's a quadratic equation. They're telling me that. Because I have 1, 2, 3 unknowns, I'm going to need 3 separate equations to find A, B, and C. And as I look right here, these guys right there, they are not at all unique points, meaning they are not the vertex, they are not x-intercepts, they are random rogue points. So what I'm going to do is I'm going to find out, and I'm going to use my first point of 3, 20. And I'm going to say this first equation is going to be 20 equals 3 squared is 9 times a gives me 9a, plus 3 times b gives me 3b, plus c. And I'm going to call this equation number 1. Okay, that's my equation number 1. I really got to track my work big time here. My next one is going to be negative 1 comma negative 4. Well, my y is negative 4 equals negative 1 squared is 1 times a just gives me an a. Negative 1 times b gives me minus b plus c. And I'm going to call this one equation number 2. Okay. And then I got to use my last and third point of negative 5 comma 4. And that's going to give me another equation of 4 equals negative 5 squared is 25 times a gives me 25a. Negative 5 times b gives me negative 5b plus c. And I'm going to call that one equation number 3. Okay, so there's 2 and there's 3. So now I have 3 equations, 3 unknowns. So now what I need to do is I need to rewrite. I need to find out what I need to build these down, and I need to eliminate one variable at a time using all of my equations. So what I'm going to do here, if you track my notes, I'm going to take equation number 1. Okay, I'm going to keep it red. I'm going to say I'm going to take equation number 1. And I'm going to take equation number 2, and I'm going to multiply that one times negative 1. Give me that. I'm going to multiply that times negative 1. And what that is going to give me is equation number 1, that's simply 20 equals 9a plus 3b plus c. But if I take equation number 2 times negative 1, I'm going to have 4 equals negative a plus b minus c. So when I add these together, I can eliminate C. Okay, and I get 24 equals 8A plus 4B. Okay, and of course, I have a new equation. This one only has two variables in it, but I'm going to call this one number 4 so you can track my work. And hopefully you label these this way. You know, if I made a mistake already, I'm kind of hosed, and the whole answer is going to be wrong. That's what makes these fun and a lot of work. So I utilized these two equations. Now I need to utilize my third equation with either 1 or 2, but because I eliminated C first, I need to eliminate C in this one as well. So what I'm going to do is I'm going to take equation number 3, okay, and then I'm going to take equation number 2 again, and I'm going to take that equation number 2 times -1. Okay, and what I get when I get that is equation 3 is going to be 4 equals 25A minus 5B plus C. I didn't do anything to number 3, but number 2, I'm multiplying by -1 just to pair these two together. So I'm using them all at the same time. That's going to give me what? 4 equals -A plus B minus C. So now I made my C's opposite, so I'm going to eliminate them. And when I do that, I get 8 equals 24A minus 4B. And for my tracking purposes, I'm going to call this one, you guessed it, equation number 5. Okay? Now notice I have two equations, and they each have an A and a B. So what I'm going to do is I'm going to use these two, and I need to eliminate either variable A or B. Now when I look at these, I can see my B terms already are opposites. So all I'm going to do now is I'm going to come back, and I'm going to take equation number 4, and I'm going to start over here. I'm going to take number 4, and I'm going to take number 5. And all I'm going to do, because I see their opposites already, equation number 4 is going to be 24 equals 8A plus 4B. And number 5 is 8 equals 24A minus 4B. That when I add these two together, I have now eliminated my B term. And what comes out is, what is that going to be? 24 plus 8, that would be 32 equals 32A. And when I divide it out, I have just found A equals 1. So I know back here, this guy is going to be the number 1. Okay? Now I need to find B and C yet, but this is the chain reaction backwards. Notice, either equation 4 or 5, it doesn't matter which one you pick. Equation 4 and 5 each only have an A and a B. So if I plug my A into, say, equation number 4, let's say I plug A into 4, plug A value into number 4, what happens is I get, what do I get? I get 24 equals 8 times 1 plus 4B. Well, that gives me 24 equaling 8 plus 4B. Well, that tells me 4B equals 24 minus 8. What is that? That's 16. So B actually has to equal 4. So now I just found out B equals 4. So when I write my function, yeah, I know that guy is going to be 4. Now I need to know C yet. So what I did was, after I found my A value, I took that A value and I brought back to a previous level. Now I know both A and B, and now I got to go all the way back to the top, and I'm going to pick the easiest equation. Is number 1, 2, or 3 going to be the easiest one to work with? I totally think number 2 is the easiest one to work with because it has the smallest numbers in it. So now I'm going to come down here, back down to the bottom, and I'm going to plug into that, plug A and B into number 2. So what I have is I take -4 equals A minus B plus C, just so you say that's my equation, that's my number 2 here, okay? So I'm going to say -4 equals, my A value is 1, minus my B is 4 plus C. So I can see -4 equals -3 plus C. So that would mean C has to equal -1. Okay, so now I know A, B, and C. So when I take that back all the way, when I take that all the way back to the top, okay, I'm going to stop here a quick second. Out that this C value right here, this C is -1. So when I plug A, B, and C back into my function, what I find is I find the function I'm looking for, and I can say f of x actually equals, A was 1, so I have x squared plus 4x minus 1, because I'm actually taking ax squared plus bx plus c, and I'm plugging in A, B, and C. So what you could do to check this out is you could actually type that into Desmos, okay? And on that, you could go in there and you could verify that there's only going to be one parabola in the world on the Earth that is going to go through all 3 of these points, okay? There's an infinite number of parabolas that will go through 2 points, just like there's an infinite number of lines that will go through 1 point. It takes 2 points to make a unique line, and it takes 3 points to make a unique parabola. So if you graphed your parabola in Desmos, it is going to pass through all 3 of these points. If it does not pass through those 3 points, that means we made a mistake. Okay? If you really got it here, you can bail out of the video. If you didn't, I'm going to do one more example here, and I'm going to kind of do them the same way. And this one's a little bit more technical, but because I need a system of equations, I'm starting with 9, 3, and I'm going to plug them into my f of x equals ax squared plus bx plus c. This is how I'm utilizing my equations. So 3 equals 9 squared is 81 times a gives me 81a plus 9 times b is 9b plus c. Yep, I'm calling this one number 1. Then I'm going to come over here and I'm going to use my next point of 6, 3. And I'm going to say 3 equals 36a plus 6b plus c. And that's going to be number 2. And then I'm going to take my last point of 4, 27. And I'm going to say 27 equals 16a plus 4b plus c. You guessed it. That is number 3. And from here, what I'm going to do in my work is I need to eliminate. You know, the c value is always the first one to eliminate if you don't know what it is. Because all I got to do is I'm going to take my equation, I'm going to take number 1, and then I'm going to take number 2, and I'm going to take number 2 times -1. And what that's going to give me is 3 equals 81a plus 9b plus c. And then 2 times -1 gives me, what does that give me? -3. And I dropped the sign way back here. That's 9, -3. Sorry about that. So that's negative. And that's going to equal -36a minus 6b minus c. So when I add these, I eliminated my c's, and I get -6 equals 45a plus 3b, and I'm calling that guy equation number 4. And I can pair these equations up in any way I wanted. I chose to multiply number 2 by -1 because I saw equation number 1 had bigger numbers, therefore I would have fewer negatives in equation 4. And what I'm going to do next is I'm going to take actually equation number 2, and then I'm going to take equation, because number 2's got bigger A's and B's in it, or bigger A's in numbers, and then I'm going to take equation number 3, and I'm going to take that guy times -1 this time. And what's going to happen is number 2 is 3 equals 36a plus 6b plus c. And sometimes you need to multiply both of them by things. This is going to give me -27, and that's going to equal -16a minus 4b minus c. So as I add these together, I eliminated c, and what I get is -24 equals, what do I get there? 20a plus 2b. And, yup, I'm calling this one number 5. And when I look at equation 4 and equation 5, okay, it's kind of a pain in the rump because I don't have the same number or anything. So what I'm going to choose to do here is my smaller numbers are on the b's. So I'm going to take number 4, and I'm going to take number 4 times 2. And then I'm going to take equation number 5, and I'm going to multiply that one by -3, so I can get opposite coefficients on the b. One will have a +6, one will have a -6. So when I take my equation 4 times 2, I get -12, right, equals 90a plus 6b. And when I take equation 2 times what my -3, equation 5 times my -3, what I do is I get 72, because -24 times -3 is 72, equals -60a minus 6b. And what I have just done, so I add these together, I have eliminated my b term, and what I get is 60 equals 30a. So A has to equal 2. Yay! I finally got an A value. Look at all that work people are going to tell me they did in their head. Look at that. So I know A is 2. Now I got to take that 2, and I'm going to come back to equation 4 or equation 5. It really doesn't matter which one it is. I'm going to pick equation 4 just for fun, and I'm going to plug my 2 into number 4. Plug 2 into number 4, okay? And to do that, that's going to give me -6 equals 45 times 2 would be 90 plus 3b, and lo and behold, look at there, I got a b. 3b is going to equal -96, so b has to equal -96 divided by 3 is -32. Now I have B. Now that I have A and B, now I got to take both of those, and I got to come back to any one of these original ones that are the easiest to use. To me, it really doesn't matter. A is going to multiply by 2, so I'm going to pick my smallest. The numbers are smallest really in number 3, so I'm going to take number 3. And my equation number 3, because it's not on I'm going to say number 3, and what it was in the beginning was it was 27 equals 16a plus 4b plus c. So what I'm going to do is I'm going to plug in these two into that equation, and what I'm going to get is I get 27 equals 16 times 2 plus 4 times -32, and when I'm all done, I'm going to have C. So 27 equals 32 minus 128 plus C, So 27 is going to equal 32 minus 128 gives me negative 96 plus C. So C has to equal 123. I have found A, B, and C. Because I have found A, B, and C, I'm going to plug A, B, and C back into AX squared plus BX plus C to say my function, my parabola that passes through these points are A was 2, so it's 2x squared. B was negative 32, so that would be minus 32x. And C was 123 plus $1.23. And that gives me my parabola that passes through the 3 original points. You can plug it in and you can make sure that it goes through those 3 points. Technically, the algebraic way to do it would be take all 3 of these points one at a time and plug each x and y into this function, and you should get the same number equaling the same number 3 times. And that'll sum it up. We'll be online for help for you if you need it. Have a good afternoon.